Hello, everyone. This is Team Vyadh, and we are part of a larger team with 34 members, and we build Mars rover prototypes. You might have seen us in Insta. I am Anbu. I am the electrical head, and this Tanmay, who is an electrical junior, and Santosh, who's a software junior. So here in today's hackathon, we built Project Sentry, about which Santosh will explain further.
Project Sentry is a distributed early detection for forest fire system using mesh networking and TinyML models. Essentially, each of these nodes are low powered and they are intelligent enough to detect the acoustic signatures of a forest fire before they start to spread. Traditional approaches include like CO2 sensors or computer vision based approaches, but the problem with that is that CO2 sensors, by the time there is enough CO2 in the air to detect, it is probably a little too late to stop the forest fire from spreading. And with computer vision, it is computationally intensive, so it takes a lot of power. Our system, on the other hand, is very low power that it can run in theory perpetually with the solar panel and the battery pack that we have provided. I would like to show like a small demo right now. Like first, I will explain the hardware that is in front of you right now. This is the main product node that we've built with the 3D printed enclosure and the solar panel and everything. This is actually a breakout of everything that's there in the product. That is the microcontroller, and there is the microphone, the battery pack, and we've also connected it to an ammeter just to see how low power it is. Right now, it's actually pulling anywhere between 90 to 100 milliamps, and that is while it's performing the machine learning tasks. So it takes a lot more. However, we have a system where the microcontroller goes into deep sleep every now and then to conserve power. And because it's a self-healing mesh network, when one node is sleeping or one node has low battery, the other nodes can increase their sensitivity as to cover for the slack left by the other one. And finally, the thing that you see right here is the gateway node. It is also a microcontroller that listens for the BLE packets sent by the other nodes of the network. And finally, on the laptop, this is the GUI that we have built to basically have a look at everything that's going on. Right now, you can see the total number of nodes, the total number of online nodes. If we can zoom in a little bit, we can see the last scene as to when the last heartbeat from each of the nodes is. And we can also see the fire report, if any, and the number of nodes confirming the fire. So we will now be playing an audio of leaves cracking and burning wood. Once that happens, you can see each of the nodes start to detect the fire. As you can see, one of the nodes has actually detected the fire already, as indicated by the blinking red node on the map. Right. The other nodes should also start picking it up very soon.
It's in deep.
Right. So it is in deep sleep. When it wakes up, it will detect the fire. Okay, yeah. You can see that both the nodes have actually detected the fire, and you can see the location of each node as well. The way we figure out the way we localize the nodes is based on the node ID. Each of these nodes have an individual ID that you will assign when you place them in the forest. The whole idea is that you place them once and you kind of forget about it because it is solar powered, and in theory, it should run perpetually. So
Very
that's
cool.
about the technical demonstration.
Very cool. Like after the hackathon, what are you guys looking for?
We are looking to expand this. We are looking to introduce more nodes. Right now we have only two nodes to demonstrate. What works in two nodes wouldn't completely work in let's say 10 nodes or 100 nodes, which is what we are targeting towards. So we are looking forward to creating multiple nodes and testing it in a real environment.